I'm KL Rajeshri, Assistant Professor, Department of Mathematics, Bharat Institute of Higher Education and Research. We are going to deal with the course name Numerical Methods, and the course code is U18 MS BS MA 401. So we are going to discuss the unit 3, numerical differentiation and integration. So the topics in this unit are differentiation using interpolation formulae. The next is numerical integration. In that you have trapezoidal rule, Simpson's 1 by 3rd rule, Simpson's 3 by 8 rule, Romberg's method. Then you have 2 and 3 point Gaussian quadrature formulae. Then you have the topic double integration. There you have trapezoidal rule as well as Simpson's rule. So next topic we are going to discuss is numerical differentiation. So what is numerical differentiation? Numerical procedures differ from the analytical methods of calculus in that it can be applied to functions known only as a table of values as well as to a function stated explicitly. So numerical procedure differ from analytical methods. So in that it can be applied only the table values or as well as to a function stated explicitly. The functions should be stated explicitly. Now to get the derivative, we first find the curve y equal to f of x through the points and then differentiate and get its value at the required points. Next is if the values of x are equally spaced, we get the interpolating polynomial due to Newton-Grigori. So next is we are going to deal with Newton's forward difference formula. So if the derivative is required at a point nearer to the starting value in the table, we use Newton's forward interpolation formula. So your y is equal to y naught plus u into del y naught. The del is called the forward difference operator plus u into u minus 1 by 2 factorial into del square y naught plus u into u minus 1 into u minus 2 by 3 factorial into del cube y naught, etc., etc., where u is given by x minus x naught by h. So x naught is the initial value, x is the variable, and h is the interval. So what is the derivative? It is denoted by dy by dx. Here y is a function of a variable y, u. So first we have to differentiate y with respect to u. So dy by du into, next we have to differentiate u with respect to x. So into du by dx. So your du, y is not directly not directly an explicit value of x. It is y is given as a function of u. So directly we cannot find the derivative of y with respect to x. So first we are differentiating dy y with respect to the variable u. Then we are finding the derivative of u with respect to x. So that's how you got this. So that is 1 by h into del u naught plus 2u minus 1 by 2 into del square into y naught plus 3u square minus 6u plus 2 divided by 6 into del cube y naught plus 2u cube minus 9u square plus 11u minus 3 by 12 into del power 4 y naught, etc., etc. So it is an infinite series. So next is Newton's backward difference formula. So if the derivative is at the end of the table, we use Newton's backward interpolation formula. So your y, so as it is backward interpolation, you will have del, that is the far backward difference operator inverted del. So your y is equal to yn plus u into del inverted del into yn plus u into u plus 1 divided by, there it is u minus 1, here it is u plus 1. So u into u plus 1 by 2 factorial into del square yn plus u into u plus 1 into u plus 2 by 3 factorial into del cube inverted del cube yn, etc., etc., where your u is equal to x minus xn by h. Previous thing it is x minus x naught by h. Here as we are going to find the derivative at the end of the table, we are using the value xn. So your u is equal to x minus xn by h. So your dy here also the same thing. We are first to find the derivative of y with respect to x. So y is not directly value of x, so we'll find the derivative of y with respect to u first. So dy by du into du by dx. So here the derivative is given by, that is equal to 1 by h into inverted del yn plus 2u plus 1 by 2 into inverted del square yn plus 3u square plus 6u u plus 2 divided by 6 into inverted del cube yn plus 2u cube plus 9u square plus 11u plus 3 divided by 12 into inverted del power 4 yn, etc., etc. It is an infinite series. Now we are going to discuss with Newton's forward difference formula. So you are going to discuss a problem. The problem is obtain the interpolation quadratic polynomial for the given data by using Newton forward difference formula. So our x values are given as 0, 2, 4 and 6. Your y values are given as -3, 5, 21 and 45. So we are going to form the difference table. So we'll write x values first as the first column, y values, that is f of x, as the second column, the first derivative del y as the third column, the second derivative del square y as the fourth column, and the third derivative del cube y as the fifth column. So first we are writing the values of x given as 0, 2, 4 and 6. Next we are writing the values of y as -3, 5, 21 and 45. So like we have discussed in the previous unit, we are going to find the derivative del, first derivative del y. So from 5, we have to subtract -3. So 5 minus of -3. So that will become 5 plus 3, that is equal to 8. Then you will have 21 minus 5, that will give you 16. Then you have to find out 45 minus 21, that will be 24. So you have got the first derivative as the third column, 8, 16 and 24. Next we are going to find the second derivative, that is del square y. So that is 16 minus 8, that will give you 8. Similarly 24 minus 16, that will give you 8. So you got the second derivative, that is del square y. Both are 8 and 8. So the third derivative, 8 minus 8, will become 0. That's how you form the difference table. So we are going to use Newton's difference formula, forward interpolation. So Newton's forward interpolation formula is y is equal to y naught plus u into the forward difference operator del y naught plus u into u minus 1 by 2 factorial into forward difference operator, that is del square y naught plus u into u minus 1 into u minus 2 by 3 factorial into del cube y naught, etc., etc. So your u is given by x minus x naught by h. So the initial value x naught is given as 0. So the initial value is 0. So you will have your x naught as 0 and the interval is 0, 2, 4 and 6. So from between two intervals, that is 2 minus 0 is also 2, 4 minus 2 is also 2, 6 minus 4 is also 2. So the interval is 2. So you will be getting u is equal to x minus x naught by h, that is x minus 0 by 2, which is equal to x by 2. So your y is equal to, what is the value of y naught? Y naught is -3. So -3 plus what is your u? It is x by 2. So x by 2 into, what is your del y naught? It is the first value 8. So x by 2 into 8 plus u into u minus 1. So you'll be getting x by 2 into x by 2 minus 1 divided by 2 factorial into your del square y, that is also 8. So into 8 plus third derivative vanishes, so it will become 0. So -3 plus x by 2 into 8. So 2 and 8 get cancelled, you will get 4. So 4 into x, it is x. So x by 2 into x by 2 minus 1 divided by 2 factorial. So 2 factorial is 1 into 2, that is 2. 2 and 8 get cancelled, so you'll be getting 4. So x by 2 into x by 2 minus 1, if you simplify, you will get x into x minus 2. So you'll be getting y is equal to minus 3 plus 4x plus x into x will become x square. X into minus 2 will become minus 2x. So if you simplify, you'll be getting x square plus 4x minus 2x will become plus 2x minus 3. So you will get a quadratic polynomial, that is y is equal to x square plus 2x minus 3. So using Newton's forward difference formula, you have find the um, y as a quadratic polynomial. So based on this, we are given two problems. Find a polynomial of degree 2 for the data by Newton's forward difference formula. So your values of x are 0, 1, 2, 3, 4, 5, 6, and 7, and the y values are 1, 2, 4, 7, 11, 16, 22, and 29. Next question is, from the following data, estimate the number of persons earning weekly wages between 60 and 70 rupees. So wages, it is given below 40. It is a number of persons is 250. 40 to 60, it is 120. 60 to 80, it is 100. 80 to 100, it is 70. And 100 to 120, it is 50. So as they have given as an interval, you can divide it as 40 plus 60 will give you 100. So 100, if you take the average, it will be below 50. Next, 60 plus 80, it will give you 140. So 140 by 2, you can take it as 70. Similarly, 100 plus 80 will give you 180. So 180 by 2 will give you 90. Like that, you can proceed, and you can use the forward interpolation formula to find the number of persons earning wages between 60 and 70. Next topic is interpolation. So interpolation, you have the introduction like this. The estimation of values between well-known discrete points are called interpolation. So if the estimation of values are between well-known discrete means different points, then it is called the interpolation. So interpolation is the process of finding the most appropriate estimate for the missing data. So for the missing data, interpolation process is a process we are using. So for making the most probable estimate, it requires the following assumption. So for doing the interpolation, we are assuming two things. The assumptions are given here. The frequency distribution is normal and is not marked by sudden ups and downs. The frequency should be distributed normally, and it should be taken care that there should not be sudden ups or not sudden downs. And next assumption is the changes in the series are uniform within a period. So after a particular period, the changes should be in the series should be uniform. So we are taking it for a particular period. In the period, the changes in the series will be uniform. Within the period, the changes should not be sudden, or it should not be non-uniform. So these are the two assumptions for doing interpolation. Next is, what is the difference between interpolation and extrapolation? So it can be asked as a 2-mark question. Define interpolation and extrapolation. So the process of finding or computing the value of a function inside the given range is called interpolation. So if we are computing the value within the given range, then it is called the interpolation. The process of compute the value of a function outside the given range is called extrapolation. So if you are doing the calculation outside the range, then it is called extrapolation. So it can be asked as a 2-mark question. So next we are going to deal with the topic numerical integration. So numerical integration represents the area between y is equal to f of x, the x-axis, and the ordinates x is equal to a and x is equal to b. Ordinates means, suppose if you are referring ordered pair, the first x coordinate is called the x coordinate. The y coordinate is called the simply the ordinate or abscissa. So we are using the word for y coordinate. We are taking the ordinates at x is equal to a and x is equal to b. And this integration is possible only if f of x is explicitly given and if it is integrable. So two cases we are saying. First thing is f of s should be explicitly given. Second one is if it should be integrable. So these are the two conditions. So next is numerical integration. If we are given a set of n plus 1 paired values where we are taking is an ordered pair xi comma yi, where I varies from 0, 1, 2, etc., etc. N of the function y is equal to f of x, where f of x is not known explicitly. So as we did in the case of interpolation or numerical differentiation, we replace f of x by an interpolating polynomial p of x. So if the function f of x is not explicitly given, we did in the case of interpolation or numerical differentiation, we'll be replacing f of x by an interpolating polynomial p of x. Next is geometrical interpretation. So geometrically, if the ordered pairs xi comma yi, where I varies from 0, 1, 2, etc. n are plotted, and if any two consecutive points are joined by straight lines, we get a series of trapeziums. So geometrically, we'll be having an x-axis and y-axis, and for we are plotting the values xi comma yi, where I varies from 0. So we are plotting the points x0 comma y0. Then we are plotting the points x1 comma y1. Then we are plotting the point x2 comma y2. Then x3 comma y3, etc., etc., xn comma yn. And all the consecutive points are joined by a straight lines. So we'll get a series of trapeziums. Now the area between f of x, x-axis, and the ordinates x is equal to x0 and x is equal to xn is approximated to the sum of trapeziums. So if we add all the areas of the trapeziums, we'll get the whole value. So in numerical integrations, first we are going to see Simpson's rule. So in that Simpson's 1/3 rule. So put n equal to 2 in Newton's force formula, we get trapezoidal rule. If we in Simpson's 1/3 rule, we have to put n equal to 3. So Simpson's 1/3 rule, why it is called a Simpson's 1/3 rule is we are writing h into 1/3 or h/3. So there you have got the term 1/3. Hence it is called Simpson's 1/3 rule. So Simpson's 1/3 rule is h/3 into sum of the first and the last ordinates plus 4 into sum of the remaining even ordinates plus 2 into sum of the remaining odd ordinates. Now next is Simpson's 3/8 rule. So put n equal to 3 in Newton's force formula, we get trapezoidal rule. Here the number of subintervals should be taken as a multiple of 3. In Simpson's 3/8 rule, why it is called 3/8 rule is we are multiplying by 3/8. So it is given by 3h/8 into sum of the first and the last ordinates plus 3 into sum of the ordinates other than multiples of 3 plus 2 into sum of the remaining ordinates. So in Simpson's 3/8 rule, the number of subintervals should be taken as multiple of 3. Put n equal to 3 in Newton Cotes formula, we'll get the trapezoidal rules. Then we'll get the Simpson's 3/8 rule, where the 3/8 rule is given by 3h/8 into sum of the first and the last ordinates plus 3 into sum of the ordinates other than the multiples of 3. That means we have to leave for example, F3 we can leave because F3 is a multiple of 3. F6 we can leave, 6 is a multiple of 3. F9 we can add, so it is a multiple of 3. So the other ordinates we have to leave. You can leave F1, F2 like that, plus 2 into sum of the remaining ordinates. So using Simpson's rule, find 0 to 4 e power x dx given e0 is equal to 1, e power 1 is equal to 2.72, e square is equal to 7.39, e cube is equal to 20.09, and e power 4 is equal to 54.6. So solution, the following data is, you are given the x values 0, 1, 2, 3, and 4. You are given the y values as 1, 2.72, 7.39, 20.09, 54.6. So if it is not given also, you can use the calculator and find out. So using Simpson's rules, integral, what is the lower limit x naught to x, upper limit is xn f of x dx is equal to h by 3 into y naught plus yn plus 4 into y1 plus y3 plus y5, etc., etc., plus 2 into y2 plus y4 plus y6. So what is the lower limit? 0. Upper limit is 4. So integral 0 to 4 e power x dx is equal to, so what is the first value? It is 1. What is the last value? It is 54.6. So 1 by 3 into 1 plus 54.6 plus 4 into, what is the y1 value? 2.72. Next, what is the odd value? Y3, that is 20.09 plus 2 into, what is the even value? Even value is 2, that is y2 is 7.39. So plus 2 into 7.39. So if you simplify and if you add the terms in the braces, and if you multiply by 4 and if you multiply by 2, if you add and if you simplify, you are getting the value 53.8733. So integral 0 to 4 e power x dx is equal to 53.8733. So now we are going to compare trapezoidal rule and Simpson's 1 by third rule for evaluating numerical integration. So in Newton-Cotes quadrature formula, if we put n equal to 1, we get trapezoidal rule, whereas if we put n equal to 2, we get Simpson's 1 by third rule. In trapezoidal rule, the interpolating polynomial is linear, whereas in Simpson's 1 by third rule, the interpolating polynomial is of degree 2. Next, in trapezoidal rule, there is no restrictions on the number of intervals, whereas in Simpson's 1 by third rule, the number of intervals should be even. Next, using Simpson's rule, you are asked to evaluate these things. Compute integral 4 to 5.2 log x dx using Simpson's 1 by third rule and 3 by 8 rule. Next is evaluate integral minus 3 to 3 x power 4 dx using Simpson's rule. Verify your results by actual integration. So actual integration also you can do. If you do x power 4 dx, you will get x power 5 to 5, and you can use the upper limit as 3, lower limit as minus 3. You can compare your results after doing actual integration. Next, we are going to compare the trapezoidal rule, Simpson's rule, and Simpson's 1 by third rule and 3 by 8 rule. So we are having 4 columns. First one is the rule, second one is the degree of y of x, next is the number of intervals, and what about the order. So in trapezoidal rule, the degree of y of x is 1 and the number of intervals can be any and the order will be h square. In Simpson's 1 by third rule, the degree of y of x should be 2 and the number of intervals should be even and the order is h power 4, where h is the interval. And Simpson's 3 by 8 rule, the degree of y of x should be 3 and number of intervals should be multiple of 3. So this is how we compare trapezoidal rule, Simpson's 1 by third rule and Simpson's 3 by 8 rule. Next is Gaussian quadrature formula. A formula with 3 parameters corresponds to a polynomial of the second degree, 1 less than the number of parameters. Gauss he is a mathematician. He noted that if we remove the requirement that the function be evaluates at predeterminant x values. Next, a 3-term formula will contain 6 parameters and should correspond to an interpolating polynomial of degree 5. So formulae based on this principle are called Gaussian quadrature formulae. So Gaussian 2-point formula. So we will determine the parameters in the simple case of a two-term formula containing 4 unknown parameters. That is, integral a to b f of x dx will become integral minus 1 to 1 f of t dt, where integral f of t dt is equal to a into f of t plus b into f of t. We use a symmetrical interval of integration to simplify the arithmetic and call the variable as t. So this formula is to be valid for any polynomial of degree 3. So next is Gaussian 3-point formulae. So Gaussian 3-point formulae is exact for 5 degrees of polynomials. So hence 3 points Gaussian quadrature formula is integral f of t dt is equal to 5 by 9 into f of minus 0.77459 plus f of 0.77459 plus 8 by 9 into f of 0. So using this Gaussian 3-point formula, you are asked to evaluate integral minus 1 to 1 dx by 1 plus x square by Gaussian 2-point formula. So integral minus 1 to 1 dx by 1 plus x square can be written as integral minus 1 to 1 dt by 1 plus t square is equal to f of 1 by root 3 plus f of minus 1 by root 3, where your f of t is equal to 1 by 1 plus t square. So f of 1 by root 3 will become 0.75. So what is f of 1 by root 3? 1 by 1 plus 1 t square. So t is 1 by root 3. So 1 by root 3 the whole square. If you simplify using your calculator, you are getting 0.75 plus 0.75. If you add, you'll be getting 1.5. So Gaussian quadrature formula will be useful in calculating the integrations. So these are the things we have discussed in this units. Thank you.